Hey, hello and welcome to today's GFG problem of the day. Hope you are doing well. So let's see today's problem. Reach a given score. So there is a game where a player can score 3 or 5 or 10 points in a move. Okay. We will be given a total score of n. We want to find the number of distinct combinations to reach the given score using these 3 points, 3, 5 or 10. Okay. So for example, so total score n given is 10. Now we want to find in how many possible ways, in how many number of ways we can reach this total score 10 using 3 or 5 or 10 points. So here you see there are two ways, 5 and 5 and 10. So we can use a point in any number of any number of times we can use, right? So here we have to use two times the same coin 5. So for n equal to 2, total score 20, there are four possible ways. What are the four possible ways? So here one way is this, right? 5 we have used 4 times. Here another way is 3 we have used 5 times and 5 we have used 1 time. Here 10 we have used 2 times and 5, 5, 10, 5 2 times and 10 1 time. Okay. So they've asked us to find out distinct combinations. So here if you see the pattern, it is the points, the given points 3, 5, and 10, they're in given order, in increasing order. So if you see 3, after 3, only 5 comes. After 5, 10 comes. It's not like 5, 3, you cannot use this combination, right? Or they have not asked permutation. They've asked distinct combination. So once you use 5, you cannot go back and use 3, right? So it needs to be increasing order. For example, 3, then if you use 3, then you can use 5. And you can use 10 post 5, like that, right? So this is what they've asked. So now coming to, let's see how we'll solve, right? How we'll solve this problem. So here, so this can be solved recursively, right? For example, if n is given, if n is given, what we can do, n minus 3 we can do, right? Then n minus 5 we can do, n minus 10 we can do, right? Then n minus 6, 3, n minus 3 minus 3, right? N minus 3 minus 5, like that, right? 8, n minus 3 minus 10. So like that, right? So there can be a number of combinations, right? So in this way, in this combination, right, there can be repeating sub problems as well. So for example, so the one which you have solved, which you are solving here, it must have solved here as well. So right, so there will be repeating sub problems here. Okay, so when repeating sub problem comes, when the recursion comes and repeating sub problems comes, then naturally to optimize, we have dynamic programming with us. So what we are going to do is, so let's take this example, n equal to 10. So we'll have a dynamic array, okay, of size 10, for example, or size 11 basically, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so what we are going to do is, so now, okay, so this is the array, right? This is the array, right? Okay, let's consider this as an array, okay? And for n equal to 0, for n equal to 0, when n, that is the total score n is given, okay, the number of combination will be 1. Okay, the number of, even if, for example, if there is no score, there's no score, total score given, that is n equal to 0, there's one way, okay, to basically, there's one way, okay, for n equal to 0. To score n equal to 0, there will be one way, even if we are not using any points over there. Okay, so here we'll write 1. Okay, now what we are going to do is, as you know, right? So we have to go in increasing order, 3, 5, and 10, right? 3, 5, and 10. We have to go in increasing order. So what we're going to do is, we are going to solve for 3 first, for point 3. Okay, for point 3, we are going to solve, right? So definitely for 3, right? So what we're going to do, dp of I, right? dp of, this is a dpr, right? I plus dp of I minus 3, we are going to do, right? Okay, dp of I minus 3. So naturally, we are going to start from here because, right, for point equal to 3. So just be with me, you'll understand this. Okay. So when for 3, right, definitely for n equal to 1 and 2, it is going to be 0, right? Okay. For any combination for 0.3, 5, or 10. So n equal to 1 and 2 equal to 0, because we cannot score this if when n equal to 1 or 2, right? So for 3, it is going to be what? If we consider this, right, dp of I plus equal to dp of I minus 1. I minus 3, sorry, dp of I minus 3. So what is 3 minus 3? 3 minus 3 is 0, right? So in 0, we have 1. So we are going to use 1, right? So, okay. For 4, right? dp of 4, right? dp of 4, dp of 4 minus 3. So what is dp of 4 minus 3? It is dp of 1, right? So it is going to be 0. Okay, it is going to be 0 only. For dp of 5, for dp of 5, dp of 5 minus 3. dp of 5 minus 3 is 2. So dp of 5 plus dp of 2, it is going to be 0 only, right? So first, initially all the array is initialized with 0. Okay, the array is initialized with 0. Now for dp of 6, dp of 6 minus dp of I minus 3, right? So I is 6. So 6 minus 3, it is 3. So we'll take here 1, right? We'll take here 1. So dp of 7, dp of 7 minus 4. 7 minus 3, sorry. 7 minus 3 is going to be 4. So 4 is 0. So we're going to have 0 here. Okay. We're going to have 0 here. And then what we're going to do now, 8 minus 3. is 5. So it is going to be 0. 9 minus 3, it is 9 minus 3, it is 6, right? It is 6. 9 minus 3 is 6. So we are going to put 1 over here. Add 1. 0 plus 1, 1. Right? So dp of 10, for dp of 10, 10 minus 7, 10 minus 3, 7. So 0 plus 0, it is going to be 0. So this is the state, right? This is the state. For now, okay, we have used score 3. Okay, so this is the state of the array, right? This is the state of the array. Now let's consider for 0.5. For 0.5, right? So yes, we are going to use the same. So here is the state. For example, let's say for 0.3, here is the state. 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, right? And let's have indices as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, 9 and 10. Now we are calculating for 0.5, right? For 0.5. So what we are going to do? Again, we are going to start from here basically, right? We are going to start from here. So what we'll have till this 4 will have as is, because there's no point, right? Starting, because dp of, because for 0.5 we'll have to start from here. So now here, right? So what we're going to do, dp of this, right? So what the formula is going to be, I plus equal to, right? For example, let's consider equal to, right? Dp of I plus dp of I minus 5, right? I minus 5. So here, so 5 minus 5 is going to be 0. So we are going to add here, right? 1 plus 0. 1 plus 0, it is going to give us 1, right? Similar, dp of 6 minus 5, it is going to give 1. So it is, so dp of 6 plus dp of 1. So 1 plus 0, it is going to give us 1, right? It is going to give us 1. 7 minus 5, 2. It is 0, it is going to be 0 here. 8 minus 5, 3, right? So 0 plus 1, it is going to give us 1, right? It is going to give us 1. So 9 minus 5. 9 minus 5 is what? 4, right? So dp of 9 plus dp of 4, right? It is going to be 1 plus 0, 1. Okay. Now 10 minus 5. Here, 10 minus 5. So how many it is? 10 minus 5? 5, right? So 0 plus 1, right? So 1. So this is the state of array, of the dynamic array, dynamic programming array till 0.5, till score 5. Now we are going to calculate for 0.10, right? Score 0.10. Okay. So let's start. Definitely now we are going to start with here only, right? So what it is going to be? Everything will be same, right? Till here. Okay. Now what we're doing here is dp of 10, right? dp of 10 minus 10, right? So what the formula is going to be, dp of I equal to dp of I plus dp of I minus 10, right? Minus 10, right? So here dp of I, what is dp of I? It is 1, 1. And dp of I minus 10, I is what? 10. 10 minus 10, 0. So dp of 0, dp of 0. So we have to add dp of I plus dp of 0 plus, right? Plus 1 plus 1, 2. So it is given 2. So the final for score number 10, right? What are the total number of ways? We are going to return this. Total number of ways is 2. Here if you see, right? Total number of ways is 2. So we have got the answer in this way, right? So now let's solve. Let's solve the problem first. I'll solve in Java and then I'll show the C++ code. Okay. So, okay. So for example, let's have this array equal to new long n plus 1, as I said, right? So we have to calculate n equal to 10, right? So definitely we will have n plus 1, because, yeah, because it starts with 0 based indexing, right? And we are interested in 10, n equal to 10. Okay, now it is going to be initialized with 0 only by default, right? And dp of 0, that is when n equal to 0, there's only one way. There's one way, right? Now what we're going to do, first we are going to solve for point equal to 3, right? So we'll start n I equal to, from 3, we are going to start from 3. I less than equal to n, right? Plus I. Okay, then what we're going to do, what is the formula? dp of I plus equal to dp of I minus 3, right? Right. So here we have a state of dp with 0.3, right? Now let's write for 0.5 and let's write for 0.5. Okay, so I equal to 5. I equal to 5, and here it is going to be like this, right? And for 0.10, we'll start with what? We'll start with 10 only, right? And 10 here. So this will be the solution. Let's return dp of n. It's taking a lot of time. I don't know why. I don't know why it's taking a lot of time. Let's try one more time. Okay, I think it's running. It's taking a lot of time. So anyways, so yes, so we have asked distinct combination here. So if it would have been permutation, all the permutations, right? So maybe it would have been like this, dp of I minus 3 as well, right? Dp of I minus 3. And here it would have been dp of I minus 5 plus dp of I minus 3. It would have been like this, right? Yeah, but they've asked us distinct combinations, and that too, that we cannot use that point in decreasing order. It needs to be in increasing order. Okay. So yes, so this is solution. This will work. Okay, let's see the yeah. Now it is executed. Let's submit as well. Let's try it fast. It's taking a lot of time. Yeah. So here it is executed. Let's go to and check C++ code. We'll just check. It's almost same. So DP of array we have taken vector. DP of 0 is 1. And similarly, whatever we have done, it's the same operation. Okay. I hope you've got the solution. Please subscribe to my channel and like the video. Have a happy, healthy, and a great day. Thank you so much.